Hello, my name is Siddhant Bharadwaj. I'm a third year BTech student at MIT Manipal. In this video, I'll be demonstrating the credit card fraud detection using machine learning, which I've made as a part of an assignment for Skyfi Labs. In the first cell, these are the libraries that I've used for this project. They are NumPy, Pandas, Matplotlib, Seaborn, and Scikit-learn. We start by importing the data. We've used pandas read underscore CSV to do that, and then we see the first five rows of the data. As you can see, it has 31 columns. That is to say, it has 30 features, and one of them is a target variable that happens to being the class, which tells us whether the transaction happens to be genuine or fraud. These features are not something that we can understand because of confidentiality and transform reasons. There's something known as principal component analysis that is transformed this feature. Uh, as a good way to understand our data at first is to use the describe function in pandas. It gives us an idea about the mean, standard deviation, minimum 25, 50, 75% maximum values, and the count as well. We then go on print on all the columns that are in this data set. We've also, in order to see whether the data is balanced or imbalanced, we've plotted out the pie chart. In the pie chart, as you can see, that the fraudulent transactions are only 492, whereas the genuine transactions are of a very high order of magnitude. From this, we can easily conclude that the data happens to be imbalanced, which is something we all obviously expect in the case of credit card data. In this line, we separate our data features and target variables into X and Y. Uh, the algorithm that we've used is Gaussian knife Bayes. Uh, and one of those important things that you need to do in order to use Gaussian knife Bayes to its fullest is to use the best features. And in order to select those best features, you use select K best, which is a part of the scikit-learn library. Uh, on selecting those 10 features, we get that these are the features that will perform best and these are the features that will perform bad. And when I say bad and best, that is in terms of predicting. So we drop all those bad features and we only use the best features. That is comes with a Occam razor short of an analogy that you can use to understand this. The model's simplicity is what's going to be very fruitful. The more complex the model becomes, it is also prone to overfitting and other issues. And we can get a very good result with our best features. So that's what we do. Uh, we've also plotted the graphs between the best and the bad feature and their detection. In these graphs, as you could see, is if there's less amount of overlap, it's a good way to predict it. And these orange and blue represent the genuine and the fraud transactions. Same, we have done it for bad features to show you that there's more overlap here, and that's the reason there are bad features. We then go and split the training data, our data set into training and testing, and then we load the Gaussian knife Bayes, which is in the scikit-learn library, and we use cross-validate to train it. This is done because of the data set being imbalanced. Cross-validate basically divides the data into k cross-fold, and some of it is taken to be training, some of it is taken to be testing, and it is done it for 10 cross-folds, and on the basis of this we get a best estimator. This could be thought of as a way in which Gaussian naive Bayes is being trained in some sense. Uh, the training scores from each fold are also printed. We've selected the one with the highest training score because that's our best estimator. We've also plotted the results in the form of a confusion matrix, which is very important to look at, especially when the data is imbalanced. The confusion matrix in its diagonals contains a value of true positive and true negative, and then there are also false positive and false negative. Uh, Inaccuracy is not a good predictor in case when the data is imbalanced, because as you saw, that there are very less number of fraud transactions that are there. Even if the model were just to predict genuine transactions all the time, it will be very accurate model, but that wouldn't be a very useful model. We focus on something known as recall. The recall essentially defines out of all the fraudulent transactions, how many of them were flagged by the model. There's also a precision thing that's usually used in terms when there's data is imbalanced, that will tell you out of all the transactions that it flagged as fraudulent, how many of them turned out to be actually fraudulent. But that's not a much of a concern here, because we want to identify as many as possible fraudulent transactions. So that is what we've focused on, and you can see the scores are really good. 0.87 here, and this is for the training set, which is almost the same. Thank you for watching.